Hello, guys. Thanks for joining us today. Today we'll be talking about Docker. It's a great technology that won the world during the past 10 years. It allows you to speed up your local development, and also it's an integral part of today's cloud. And the speaker today is Evgeny Sokolchik, a person who worked with Docker a lot. So I remind you that you can ask all the questions in the chat. We will answer them, and I'm passing the word to Evgeny.
Okay, yep. Thanks, Danila. Hi, everyone. As Daniel already said, uh, my light talk will cover Docker fundamentals, or basics, you may say. Okay, let's come to the first slide, sorry. So, the Docker basics. I personally think that Docker is an irreplaceable instrument for modern software developers, and it helps to speed up and make the development process easier for large enterprises, as well as it can help you with your everyday tasks. So let's proceed to talk about uh, today's Light Talk author. My name is Evgeny Sokolchik. I'm working for EPAM for more than a year now. I participated in 3 different projects, last of which uses the Docker technology quite extensively. Beforehand, I was interested in Docker enough to play around with it by myself, and now I'm excited to share my experience and knowledge on the topic with you. Now, let's have a little bit of an introduction to the said world without Docker. Most of us at least once said the sacred phrase, but it was running on my machine. Doesn't matter if it happened to you during your work in production or before, during studying, when you tried to demonstrate some project to a mentor or friends. The workflow for this problem on production is usually the following. Some developer, perhaps you, develops an app, tests it in a local environment, and sends it out to the tester, who magically cannot run the same app which worked only minutes ago. Experienced developers may say that they only need to install and configure all the needed dependencies for their app to start running again. It's only 2 minutes, they say, but is it really? Also, nowadays, development teams may be quite large, which means you'll have to configure environment for every one of your 10 testers. The need for configuring every environment may lead to the downtime of your production during deployment, which isn't acceptable for big tech companies, even if it lasts mere seconds. So, as the meme on the right says, the idea is quite bold and straightforward. To ship the machine together with an app. And that is how the Docker was born. Now, let's introduce ourselves with the Docker. So, what is Docker? Docker is essentially a software platform to solve all the issues that we discussed earlier. With it, you can build, test, and deploy applications quickly, or even easily install any app you need to speed up your development, like some database without struggling to install it and configure specifically for your OS. But how is it working? Using Docker containers, of course. These are the packages that contain all your working environment. Basically, your machine is now shipped everywhere, and it is ensured by the container specifications that they will run on any other system with a container runtime. We'll dive into those later. And the last sweet thing is Docker's full most sorry, the last sweet thing is Docker's almost fully open source, which puts a smile on faces of most developers. So that brings us to a discussion on what Docker is working with. There are 3 major elements, which are a Docker file that can be built into an image, which can be used to run a container. Let's quickly review 3 of those. A Docker file is essentially a set of steps required to configure a new image. An image is just a read-only template with instructions for creating a Docker container. You can think of it as a class in Java, and a container is a runnable instance of an image, which sounds kind of similar to an object from Java. So containers can be created, started, stopped, moved, or deleted using the Docker API. The next topic is Docker architecture. Docker works using a client-server model of architecture. Client is communicating with the host through CLI or Docker Desktop Graphical Interface via messages compatible with the Docker API. Therefore, the client is only a sender of messages or Docker commands, while host is the main part of the system. It contains all the images and containers that are running or stop now, and a Docker daemon, which receives the messages from the client and does most of the work. That includes building, running, and distributing your Docker containers. Such an architecture gives Docker flexibility to run a client on host or hosts on different machines or on the same one. There are also lines to something missing on this scheme on the right, so let's find out what it is. And it is a Docker registry, another important part of the Docker system. A registry is used to store and distribute Docker images, so it's basically a warehouse for the images. It's also another part of the system that can be running locally or on a remote machine. You can create your own server where you will store built images and share those with your team. There are existing Docker registry services like Docker Hub, which is the most popular of them. There you can find tons of pre-configured images. Some are uploaded by users like us, while some of them are official and were created by developers of software that comes in those images. Those developers know exactly how to package their products better and keep an eye on the current problems. All that makes official images the best choice if you want to use some tools hassle-free. And it is time to look on some hands-on example of using Docker. Let's explore commands needed to run a simple container using Docker CLI. So firstly, we have to search for a needed image on Docker Hub. And the picture on the right shows a page with the official build of Nginx, quite popular web server. Then, when we found our image, we can pull it using the Docker command docker pull with parameters of image name and a tag, which is optional really. You can always go ahead and just use a Docker run with some options. There are lots of them, and we'll discuss some of them, and image name to run the container using the image. This image will be pulled automatically. And finally, you can use Docker stop with the container name to stop the running container. And now it's a demo time. Let's hit this run button and try to launch our container. Okay, so here is the CLI. We can just use commands docker run parameter d to run container detached. So the control will be returned to us after running the container, and it will not stay with the container. And parameter p to bind ports. Port 8080 on our host machine to the port 80 on the container. Using this feature, we can run several applications in different containers that can run only on the same port. For example, if you have two databases that run on port 80, we can have two containers, one of which will be bound to the port 8080 of our host machine, while the other one will be bound to the port, I don't know, 8070 maybe. And this way we can use both databases using the only one host machine. So let's click the enter and try run it. Oh, sorry, I forgot the most important thing, the name of the container, of course, of the image. So it was unable to find the image locally, and it is pulling it automatically. And yep, we've launched our image. It returned the full version of ID of a container. So we'll return to that later. Now, let's move on to the next slide. Well, maybe after that short demonstration, you have any questions? Daniela?
Yeah, we have one for now, and maybe you will appear. The question is, in what registry do projects usually store their images? So I think it means,
Which
is
is the
it
most popular?
Docker Hub, or it's some other repository registry?
Do you mean projects when they are being developed?
Yeah, I think so.
Well, yeah. Usually they are storing their images in their own repositories, which can be started up on some servers, which are accessible only by the team that is developing the project. So you can just, as I already said, build your own warehouse of images, which will be accessible only to your team.
Yeah, it's much more secure than storing your images in the Docker Hub. And yeah, actually, I would like to add that you don't have to build something. All modern cloud providers have the services. You can launch your Docker registry just in a minute without any code. So AWS, Azure, GCP, they all have this option. Okay, I don't see any more questions for now. I think we can go further, but guys, if you're watching this on YouTube, uh, please press likes. It really helps us. Oh, actually, we have one more question on our
Okay.
community page. Is Docker Hub an online service like GitHub?
Well, you may say it's kind of similar because it helps you to share your projects with the world. But of course, there are lots of differences. But yeah, you can say so.
Yeah. Okay, let's go further, and all other questions we will answer later.
Okay, so let's proceed. Next topic I want to cover is containerization versus virtualization. As you can see on these simple schemes, these approaches have some differences. For individual machines, you'll need a supervisor running or hypervisor running guest OSs for every app you want to run in a separate VM. However, when using containers for the same purpose, you only need a container engine inside your OS, which will run apps in separate containers without any need for installing additional operational systems. So the second option, which is containerization, is clearly more efficient. But let's discuss it a little more and add additional points on container advantages. Containers provide us with consistent environment, which means that their state stays the same unless you want it to be the other way, unless you change it with your own hands. It's better to say. Uh, Containers are platform independent, which gives them much more flexibility. No need for additional OS means that they are lightweight, and it also gives the opportunity for faster builds and application launches. And now it's even more demo time. Let's continue where we left over. Let's look at our running container. We'll use the command docker ps to show container with running engines. So as you can see, it has an ID, it has a name. It was created 4 minutes ago. It's up for 4 minutes, ports, and here we have its name. It's image name and a container name. Because we didn't specify the name by our own hands, the image name, the container name was given by Docker automatically. Okay, so now let's stop our container and use the container name. And now the name is returned. So let's see, we have no running containers, so the container is stopped now. Now let's try to, oh, I forgot to do some really important thing. So let's run the same container with the same options. The DP parameter is like D and P separately, but we can just write them together. Let's run nginx once again and try to access it from our local machine. So we'll use host 8080. Yep, we can see that we've accessed the nginx. Now, Let's stop once again, but it has another name now, so we'll just use a part of an ID. Yep, it's stopped now. So now let's try to run the container and bind it to another port. For example, 8088. So now we have it. And let's change the number. And yeah, as you can see, we're still connected to Nginx. Okay. So now let's try to execute some command inside the container. We'll use the command not docker run, but docker exec with the ID of a container. We can use only a part of it once again. And the command will be ls for Linux to list all the directories and files. And there we have it. We've executed the command inside of the container. Now let's try something more interesting. Let's write docker exec with an IT flag, which is used to stay inside the shell and avoid returning control immediately to ourselves. And once again, we'll use the part of an ID, and we will try to access the shell of the container. And there we have it. From here, we can use like a curl tool to try and access our Nginx. But it cannot connect because our Nginx is bound to the port 80 inside of a container. Well,
I think you should curl localhost 80, not just 80.
oh, sorry. Yeah.
Live demo always
Live
happens.
demo, yeah. So yeah, on the port 80, it gives us the response. So we are connected. And now let's quit the shell, exit, okay, and run another image, which is called busybox, which is basically Linux, and it just stops immediately if we want to specify any command. I'll show you. It's docker run busybox. Oh, it ran like it should. It's just quit it immediately. So now let's use docker run busybox ls. And yep, it gave us all the files inside. So let's try another interesting command. Let's run this busybox with an environment variable a, which is equal to 1. Now we can see that there are some environment variables inside that container, and the variable a equals to 1. Then let's try another interesting command, docker run, using memory parameter. We can set limits for memory usage for container using the CPUs command, the same for CPUs. And run another Nginx container. Okay, I forgot to add dashes here. Of course, it's a parameter. So, okay, suppose something has gone wrong. Of course, always a live demo. Um, okay, let's just use another terminal window. Close previous one, docker ps. So yeah, we have the Nginx container that is running. Let's try to see its stats. This is the one that we needed. No, it looks like it's the first one. Okay, so using the stats command, we basically can see the memory usage and the CPU's usage, well, all the resource usages of a container in real time. As you can see, it is updating right now. So that's all for the demo. Proceed to.
Let's probably answer a few more questions. We
okay.
have several. Yeah, the first question is, can I have my own repository for images to pull from? How it will look like on practice? I think we answered this question. In practice, you go to AWS or Azure or whatever cloud you use and just spin a new, well, it's not repository, it's, how's it called? Not repository, registry for your containers. Yeah, it costs not a lot, I think few dollars a month, maybe less, depending on the amount of your images, and you pull from it, yeah, as you pull from the Docker Hub. Okay, and the next question.
I can also add something.
Yeah.
Well,
Yeah, sure.
when you're having Docker on your local machine, you're basically having your own local registry when you're saving your images, you're building your images. So you always have your own registry, but if you want to have it on some separate server, yeah, you might use some services like Amazon, Azure, or you just can search for instructions on internet on how to configure it yourself. But it's difficult, so better to use services.
Yeah.
Okay.
How does the client know to which Docker registry to connect?
How does the client know? Well, by default, if I'm not mistaken, it is Docker Hub, but to connect to the specified registry, well, I don't remember, I think.
Yeah,
Really?
you don't do this often. From what I remember, there are some global settings. So you set it once and you connect to the required registry. And also, I think that in all commands, you can override the registry you're working with. So if you want to execute just one command against some registry, you can do it without configuring it globally. I hope it answers your question.
Oh, yeah, sounds about right.
Yeah, there is some misunderstanding about the Docker architecture. Could you please scroll back to your first slides? Yeah,
Okay.
this one. This one. Yeah, the question is, well, basically, how does it work? Should I install an instance of Docker server or there are some shared instances worldwide? In this diagram, Docker host is basically your computer. To run Docker, you have to install it locally. You just Google Docker install, download it for Linux or Windows or Mac, and you can launch it. You don't need any other servers to work with Docker. So yeah, clients and Docker hosts are your computer. And the registry is something external, but you can use Docker Hub for free if you want just to play bits with Docker. Yeah, and the next question from the same person, which software should be installed on client server side and so on. The client should install Docker Desktop or
CLI.
yeah, and that's all. And well,
Yep.
server yeah, registry, it has some other type of software, but we are not talking about it right now. I hope it became a bit more clear. I think we can go further as we don't have any more questions for now.
Well, yeah, for the default Docker installation, you always install a Docker daemon and the client, so you can just, after simple installation, use everything you need from your PC only. Okay, so after the demo, let's recap all the commands that I've shown you. After the questions, it's really important because you might have forgotten some of them. So the Docker PS is used to view all the running containers. We can use Docker stop to gracefully stop the container, or Docker kill to do it forcefully. We can use the Docker exec command to execute command inside the container. We can use the Docker exec with an IT flag and bin bash to enter the container shell. And IT flag, I'll repeat, is used to not to return control to the console from the container, which we want to have access to shell in. And the next command is docker run with an e parameter, which helps us to set environment variables. And docker run with memory and CPU's parameters helps us to set resource limits for our container. And docker stats helps us to see resource usages for our container. Okay, so now let's look simple Dockerfile instruction. Let's recap a little bit. Dockerfile is a set of instructions that is required to build an image. So we are building an image from a Dockerfile. And this Dockerfile has only 4 lines. It's quite simple. Using the first line from OpenJDK 17, we define the base image, which is somewhere on Docker Hub, and its version. So it is an OpenJDK image with the version 17. And then the next command, copy, helps us to copy files from current folder to the app folder in the container. So we're using dot to specify the current folder, the /app, the folder on the container. Then we use the run command to execute some command in the container. In this example, it's cd, so we just open our app folder. And the last command, cmd, executes the last commands in the Docker file and exits it. So here we're just running our Java application. And to build our previously shown Docker file, we can use the following command: docker build -t demo -f dockerfile dot. Dot is really important. Some people forget it really very often, so don't forget it. Well, -t demo is a tag used to run an image later. -f is a Dockerfile name, which is optional because usually Dockerfile is named Dockerfile. And as I already said, dot is the path to the directory in which the Dockerfile resides. So it's time for some more demo. I'll show you an application, very simple one, very straightforward one. It's just a simple hello world. And I'll show you how we can use the Dockerfile, which is very similar to the one in the presentation, which I already showed you, to just build an image. Okay, so I'm using the docker build command, the demo, f Dockerfile. Let's do it for now, and dot. So now our image is building, and in this Dockerfile we specified copying some artifacts from our build libs folder of the projects to the demo jar file in the container and running it later. So let's use docker run and attack demo, and it works. We get a hello from Java. So that's all for this little demonstration. Maybe we have some more questions.
Yeah, we have only one. What is the difference between run and CMD in Dockerfile?
Well, as I already said, when you're using a run command, it is used to execute any command in the container, and CMD does quite the same, but it is used to execute the last command in the Docker file and exit and stop the building of an image. So
Yeah,
it's the
so
last command you should specify in your Docker file.
yeah, you may have many run commands and you may have only one CMD command. And also CMD can be overridden when you launch an image. So actually we are doing it when we run BusyBox, but it's kind of advanced topic. We'll not dig into it. The main difference is, yes, you can have only one CMD. I
Yep.
think that's all for now.
And it's a command that is used when we are running our container based on an image. So, okay, let's move to the next slide. And next slide is about containerization standards. It is the very thing that allows us to run containers anywhere. It all was started by the OCI, or Open Container Initiative, which is a community organization. The main benefit of this initiative for us is that different container engines run containers the same way. Engines like Docker Engine, Containerd, Podman, Creo, or some other. So the phrase built in one place runs in any runtime is pretty much a rule which makes containers extra reliable, because everything you have in those runs everywhere, and the containers themselves run anywhere if you have a good runtime. Not a good runtime, but any runtime which can run containers. Okay, next topic is Dockerfile layers. Here's a simple scheme that shows, well, Linux layers in some Dockerfile and application layers. And if we have some app that requires a Linux installed in the container, then it would look just like this on the right. So what does it all mean and how can it be used? So here's some advice. Docker has a cache that is used every time an image is built, meaning that your second attempt to build an image using the same Docker file and the same app won't trigger any actual operations besides accessing the cache. Cache will return you already built layers. And if Docker comes over a single instruction in Docker file that was changed, or the underlying resources of which were changed, cache is no longer used. So it's always better to start your Docker file from commands that would be re-executed rarely, so we can use cache most of the time. You should try to separate your app and its dependencies. And it's a very good example because dependencies usually stay the same or almost the same during the development of an app, but your app changes every time when you want to run it. So in the Docker file, you should specify the base image. Then you have to copy your dependencies, for example, to the container, and then to copy your app artifact. So when you're doing like this, if you're changing only your app and not your dependencies, the Docker cache will be used every time to get an image with all your dependencies, and only then it will copy your image, copy your app to that image. All of it helps to reduce the container build time and reduces wasted cache space in your system. And this picture shows it quite well. You basically have to layer your layers by update frequency. The most frequently updated has to be as far as it can be from the base image. Now let's discuss Docker Compose. Docker Compose is a software used for defining and running multi-container Docker applications or simply systems of interconnected services. Its benefits are fast and simple configuration, secure internal communication with containers, portability, and CI/CD support. Also, an efficient use of resources. Docker Compose is configured with the Docker Compose.yaml file, and main Docker Compose commands are pretty straightforward. You can use Docker Compose up to set up your system, and Docker Compose down to tear it down. And now it's 7 more demo time. During this demo, I'll show you how to launch PostgreSQL database along with pgadmin tool and connect to the database using it. But firstly, let's review the Docker Compose file. Here it is, a simple Docker Compose file. I'll make it just a little bit bigger, if it's possible. Okay, it's quite hard, so let's just use our idea. The same. At least it's more visible. Okay, so here we have a version of a Docker Compose YAML file services. Yep, it should look. I'm doing it for your better visibility. So okay, like that. We have services, Postgres and pgadmin, which are basically just the containers. They have their own names. They have their base images. So all things we already know. Also some environment variables. For the Postgres database, it's the user and the password. And also specify the ports that are binded 5432 on our host machine and 5432 on the container. And the same with the pgadmin tool, the environment variables, and the ports. So now let's use the Docker Compose app from a directory which has the Compose YAML file in it. So Docker Compose up, and our Postgres service starts to initialize itself. And pgadmin tool is doing the same. Okay, now we can try and access our pgadmin tool at localhost 5050. And yeah, we've got it. We've specified email ipamcom as a login in environment variables, password admin. So yeah, now we're using the pgadmin. Now let's try to register a server. Let's give it a name, server. Yep. Host will be Postgres, port 5432. And let's give password. Let's change username and save it. Oh, of course, password is not secure. It's only an admin, so we won't save it. And now we have the server. We can access our databases on the server, access schemas, tables, create our own schemas and tables. So basically, we have a system of a pgadmin and PostgreSQL database up in just about 2 minutes and a few minutes more to write that simple Docker Compose file. So it is very efficient and very easy to use. Maybe we have some more questions, Daniela?
Yeah, we have one question, but before it, I just wanted to mention that Postgres is relatively easy to install. So maybe here Docker Compose is not that great, but there are other types of software that are really difficult to install, or even you cannot install them on Windows. My favorite example is my personal favorite database, Redis. Uh, to install it on Windows, to run it, you have to download the sources, compile it using cmake command, specify a bunch of environment variables, and it's too difficult. And using
Yeah.
Docker, you just Docker run and you have running Redis in 15 seconds or even less. Okay, so we have only one question for now about CMD command. Should it be the last command or it can go in the middle of Docker file?
Yes, as we've already said, it is the last command. It always should be last command because it is a command that is used when you're running your container, which is based on the image that will be built on that Docker file.
Yeah. Okay, I don't see any more questions, so let's proceed.
Okay, thank you, Danila. And to the next topic. Let's briefly discuss Docker volumes. Well, there's a problem that stopping the container always means losing all the changes in the file system. For example, if we ran some container with nginx, create some directory in it, and then stop it, then when we will run it again, then this directory will be lost. So we can bind some directories from our host file system to the container to make persistence changes. When you use a bind mount, a file or a directory on the host machine is mounted into a container. We also have another option, which is creating a volume, and it is another entity in Docker along with images and containers, but don't think too much about it. Volume is very alike. It is native to Docker, and you can create it, bind it uh, to some directories in your file system, and this volume can be even shared between different containers. So if you have some crucial data for, well, maybe some of your containers or all of your containers, you can put it in Docker volume, create a Docker volume with it, and then run container, uh, giving this volume to the containers. It's just for you to know. We will not dive in it too deeply. And next topic I want to discuss is, well, somewhat additional. By no means you must know it, but I thought it's really interesting to know. And so if you're working on Linux, you can access Docker Daemon through the Unix socket, which is a Docker sock. Using this connection, you can execute Docker commands without a need for a configured client, which changes all the Docker workflow because you won't need a client anymore. You just can use the socket and connect to the daemon directly. Exposing that socket opens an easy way to hack your system. So that's why I think it's important to know anyways. You should always protect it. And the other remarkable detail is that you can mount the socket into the container to give it access to Docker Daemon. Doing so, you give this container very high privileges. It can once again open a way to hack your system through running some malicious script on the container. And it is a way to run some more containers inside the container, or Docker and Docker. Well, it sounds fun enough to me. But this is not recommended because it is an anti-pattern in some container controlling systems. And what are those container controlling systems? Let's see it on the next slide. And it's the last additional topic I want to discuss. Uh, it's called container orchestration. It's quite big, but we'll do just a quick dive for one slide. And as I said, you may describe orchestrators uh, as container controlling systems. They're primarily used for automation of container management for large systems, for resource allocation to your containers, scaling or removing containers based on balancing workloads across your infrastructure, load balancing and traffic routing for your containers, monitoring container health, and all of these, not all, but many of those container orchestrators you can see on the picture to the right. Those are software like Kubernetes, Rancher, Docker Swarm, Red Hat OpenShift, Mesos, Nomad, and others. This software is especially useful for large enterprises that may have hundreds or even thousands of containers that are running at the same time, which makes configuring of them very annoying and time-consuming, even though containers were brought to make things simpler to everyone. So container orchestrators will help you in that situation. And that's all I wanted to discuss with you. So thank you for listening, and maybe you have some more questions.
Thanks a lot, Evgeny, for your presentation. Before we go to questions, I'd like to remind you that we have a free Java online school. If you go to mjc.school, you can enroll for free and study for free. We teach from the very basics of Java, how to write your first program, and up to the clouds and modern frameworks. Okay. And back to our questions, I see only one of them now. What is the difference between Docker Swarm and Docker Compose?
Well, Docker Swarm is, as I already said, an orchestration tool for the containers, while Docker Compose is a tool that, well, they're kind of similar because you still control some containers using it, but Docker Compose is just a simple tool which you can control using the Docker Compose YAML file, while Docker Swarm is much more complex. You need to install it additionally, and to use it, I think you need to use some graphical interface, but no, probably not, but I didn't work with it, so maybe Daniela, can you help me out with this?
Yeah, I would say that the main difference is that Compose is used for running multiple containers on the same host. So as in our example, we needed to run two containers, Postgres database and admin tool. And sometimes when you develop locally, you need to run 10 applications, so your application that you're currently developing can start. In that case, you need a Docker Compose. But in the case when you have a cluster of 50 computers and you need to run 100 instances of your applications, Docker Compose cannot help here, and you need Docker Swarm or Kubernetes or some other orchestrator.
Yep, that's much more precise.
Okay, I don't see any more questions, so we will be wrapping up. If you liked this talk, please like it and subscribe. It really helps. And see you next week. Thanks, guys, for joining.
Thank you, everyone, and thanks, Danila.